class. Today I'm going to show you guys how to take the raw data that we collected in Lab 11, natural selection of Jelly bellicus, and use Excel to convert that into results that will then graph. And that graph will be able to show us the overall growth of each individual variant within the population of Jelly bellicus. So I'm going to scroll down to the first couple data tables that we filled out. And you can see that we had 4 variants to start off with and an initial population of 10 jelly beans each. We then played a game where we tried to eat the jelly beans, counted the survivors, and applied a formula to determine the initial number in the next generation for each variant. In generation 3 we introduced a variant, the spotted colored jelly belly, and that was poisonous and that had its own effect on the population as a whole, but we continued to play the game as usual, and we filled out information through 6 generations. Now we're primarily interested in the initial number of jelly beans. The reason being, the number eaten and the number of survivors will all be reflected in the next generation's initial numbers. And I've entered that data into Excel. So I'm going to move over to Excel, but you can see we've got the generation set up, the initial population for each variant, red, green, orange, tan, and the spotted variant introduced in the 3rd generation. You'll also notice that I went out to generation 7 here. Going back quickly to our lab, you'll notice that we only did the game for 6 generations. But remember, if we have this information, the number of survivors in generation 6, we can use that to calculate the initial number of jelly beans of each variant in generation 7. I've done that in Excel here, so we have as much data as possible. Now these initial numbers are useful, but in and of themselves they won't tell the whole story. What we're most interested in is not if each population is growing, but more if each population is becoming a larger proportion of the total population. In other words, are we experiencing a shift towards more red jelly beans, or are we experiencing a shift towards more tan jelly beans in this population? And the raw numbers just won't tell us that. What we need to do instead is figure out the percent of red jelly beans in each generation and graph that versus the percent of all the other variants in each generation. So as you know, when we do a percent, we need to do the individual number divided by the total number. And I've set up on another Excel sheet new headings, right? You can see here that I'm going to need the total population, and then I'm going to need to use that number to calculate the percent of red, green, orange, tan, and spotted that make up each generation. Let's start with the total population. I could manually add together 10 plus 10 plus 10 plus 10, and that will tell me my total population for generation 1. Or I can use the auto sum button up here in the upper right hand corner of Excel, and I'm going to do that. So I'm going to put the cursor over auto sum and click. Now Excel has chosen this entire row of numbers to add up, but notice I do not want to add in the generation number. So I'm going to select myself by clicking on this cell and dragging to include all the cells I want to add up. And you'll see that I've taken all the cells from red, green, orange, tan, and spotted, and I've added them all up. And you can see that reflected in the formula in this cell. I'm now going to hit enter. You can see that the total population is 40 in that cell, and that's a correct number. So instead of entering the formula over and over again, I'm going to click on that cell. I'm then going to put the cursor over the lower right hand corner of that cell until my cursor turns into a skinny cross. I'm going to click and drag all the way down, and Excel will have totaled up each total population for generations 2 through 7 now. Well, that's my total population, but what I'm most interested in is the percent of each variant. So I'm going to start with red, the percent of red. I'm going to click on my first cell. Now I'm going to need to tell Excel that I want to enter in a mathematical formula. I'm going to hit the equal button. Now Excel knows I want it to do some math for me. I know that I want to figure out how much of the red makes up the total population. So I'm going to click on this red population here. Excel has now entered that into the formula as B2, and that's cell B2 there. I want to divide that by my total population. So remember, in Excel, if you press the slash key, that will tell it to divide. I'm then going to click on the total population. you can see that then Excel is dividing the initial population of red by the total population for that generation. Now I need to put this in a percent, so I have to multiply this by 100. In order to do that, I need to hit the asterisk key by doing Shift 8 and then 100. I'm then going to, now that my formula is complete, hit Enter. I'm going to tell Excel to do that for each generation 2 through 7 now. I'm going to click on that first cell under percent red. I'm going to put the cursor over the lower right hand corner until it turns into a skinny cross. I'm going to click and drag. Now that I've clicked and dragged, you can see that Excel has calculated the percent of the red jelly beans for each generation. So in generation 7, 24% of the jelly beans are red. In generation 3, only 18% of the jelly beans were red. Now that I've showed you how to do this with the red jelly bellies, you can follow the same pattern and calculate the percentage of green jelly beans in each generation. Then you can do it for orange, tan, and spotted. For each of the first generation, you'll need to enter the formula anew. So I'll show you one more time. For green, you'll hit equal, you'll click on the initial green number, slash for divide, click on the total population, asterisk 100, enter, and that will give you your formula that you can then click and drag and use to fill in the rest of the column. Please repeat that for orange, tan, and spotted. I've already done this in another table, so I'm going to click over to that. You can see here that we have the same information. We've just now added the percent of red, green, orange, tan, and spotted for each generation as well. Now we're going to be interested in the results, and we're not interested in any of the raw data. So I'm going to show you something that Excel can do to clean up this data table a little bit for us. I'm going to hover over the B column and click and drag until I've highlighted all the information that I don't need right now. And that's going to be columns B through G. I'm then going to right click, a menu will be pulled up, and I'm going to go to hide because I don't want to see these columns anymore. So I click hide, and you can see our data table is much neater. We only have the percent of each variant for the total population from generations 1 through 7. And this is the information that we're going to want to graph. We're going to select all of this data. We'll just click and drag. Then we're going to want to insert a chart. So I'm going to click the Insert tab, and I'm going to select a chart. This time, we are actually interested in the minor fluctuations from generation to generation. We don't want a trend line or a best fit line. Instead, we want a line that's going to track each up and down movement from generation to generation. So we're going to choose a line graph. We're going to click on that button, and we're going to choose the one with data markers right here, line with markers. I've clicked, and we've got this chart embedded. Generally, we like our charts to stand alone in their own sheet, so I'm going to go to Move Chart Location in the upper right-hand corner. I've clicked that. I'm going to move the radio button to New Sheet, and I'm going to hit OK. Now, whenever you have Excel make a graph for you, you have to look at this graph and see if it makes any sense at all. And the first place that I'm going to look is on the x-axis. On the x-axis, we're going to want to track each generation 1, 2, 3, 4 through 7. Excel has created a graph where the x-axis is made up of generation, percent red, percent green, so on until percent spotted. That just doesn't make any sense at all. Sometimes when Excel graphs for you, it might put things in the wrong order. Double check that and go over to the Switch Column Row button that you see highlighted right now. I'm going to click on that, and you can see the graph is substantially changed. But take a look at what you've got. In particular, look at the legend. The legend has listed generation, but it also has listed percent red, green, orange, tan, and spotted, and it's tracking the changes in those populations over time. That seems to be what we want. So this is better than what it originally showed for us. So we switch the row and column, and it looks like this is what we want to graph. Now from the legend you can tell that we're graphing generation, which you can see on this straight, smooth line down here. Of course we don't want to graph generation. That's not any of our data points. That's just supposed to be our x-axis. So in order to deselect generation, I'm going to go to this Select Data tab, or button I should say. I'm going to press that. You can see a list of all the data sets that we've graphed here. We've got percent red all the way through percent spotted, and we also have generation. I'm going to click the generation button there, and then I'm going to remove that from the data that we want graphed. I'm going to hit OK, and you can see that generation is no longer in the legend, and that line is no longer in our chart. Now I can show you guys how to do the layout of this chart again. You'd have to go to the Layout tab, and you can see you can add in major and minor grid lines. You can label the chart as a whole. You can label each axis. All of that was covered in previous Camtasia screen captures. So I'm just going to go ahead and click on a graph that I've already done all that minor adjustment to, and you can see what your final graph should look like.